binary tree zigzag level order traversal is a very frequently asked question in Amazon interviews, Microsoft interviews, and even in Google interviews. So it is also known as spiral level order traversal. So let us see. So in this question, we are given a tree. The zigzag level order traversal for tree looks like something like this. So 1, 3, and then 2, and then 4, and then 5, and so on. It goes like this. So what we have to do, we are given this tree and we have to return a result. The result will be something like this. So this is the output which we have to return. So 1 and then 3, 2, 3, 2, and then 4, 5. So something like this. So one thing what we can notice over here is that in this index 0 index has the first level elements, first level nodes, and in the one index we have the second level nodes, which is the 0, 1 level nodes, and in the 2 index we have level 2 level nodes. Okay, so if these are the levels, okay, this is a Leetcode medium problem, and in this we have to write a function zigzag which takes root as an input and returns us an array of array, something like this. Okay, so we have to implement this kind of a function. So let us see how we are going to do this. One thing which we can notice over here is that each and every these individual smaller arrays represent these levels, and if we call them as buckets, so each and every bucket represent a level over here. So somehow what comes to our mind if we try to solve this is we have to form kind of these buckets, okay, these buckets, and whenever we are at any element, whenever we are traversing this tree, we are at element 3, so we will try to put this 3 into its specific bucket. So it is something like if we try to form buckets, smaller buckets, okay, and somehow while traversing our tree we kind of put the element into its right bucket. So suppose if we went to 1, so we will put this 1 into its respective 0th bucket at level bucket. So and then if we went to 2, so 2 should come in 1 bucket. Okay, so this is 0, 1 bucket and 2 bucket. Okay, these are just the indices of this bigger array what we have to return. Okay, so if 2 comes, 2 should be there in the level 1 bucket, and similarly 3 and 4 and 5. Now this is, if you will see clearly, this kind of looks like a normal level order traversal, right? 1, 2, 3, 4, 5, something like this, 1, 2, 3, 4, 5. So but we have to kind of form a zigzag pattern. So zigzag pattern, so what you will notice over here is that each and every odd index level is kind of reversed. Notice something, right? So see, so 1 and then it is this way, 3, 2, now it is this way, 4, 5, and if there were more levels, so it would have gone in reverse order. So that means if there was index 3, then this should also have been reverse. So this is reverse, and our even indices 0, 2, these are not reversed, these are like this only in the output. Okay, but these are kind of reversed. So 2, 3 should become 3, 2 now, something like this. This kind of makes sense, but the problem over here with what we face is that when we are traversing our tree, right, if we are at node 3, so we don't know what level it is at, right? It should also know the respective level position. So that is the problem which we face. So suppose if we got to know that, okay, the nodes level, somehow we'll write code that somehow this 3 is present in level 1. So what we'll do is, suppose if we call this whole array as result, so in result of 1 we will put in 3, and if we are at node 4, so in result of 2 we will put in 4. So something like this we'll do. But How will we get level? We'll see through code. Okay, how will we get level when we are traversing the tree, and how we will put in, and then we will at the end we'll try to flip our odd indices. Okay, odd indices, these smaller arrays. Okay, let's try to see it through code. So we have to return a array of arrays. So let's call that array as, let us call that array as results. Okay, this is an empty array for now. In this we will be putting these smaller arrays, okay, these smaller buckets if we call it as, and we will kind of return this result. Okay, so we'll now try to just traverse this whole tree, and then for traversing a tree we'll write a normal recursive function. So something like this. So let's call this function as LOT, maybe level order traversal. Okay, level order traversal. What this function takes is root, okay, root as an argument, and then, okay, so and how will we like traverse the tree? We will kind of, when we are at root, we will like next iteration we will move to root.left and root.right. We will call it recursively, something like this. Okay, so we will be moving to root.left and maybe calling this same function again with the root.right. So this is like the normal smaller, like normal traversal how we do, right? So we will just try to move, if we are at 1, so we will move to root.left and root.right, something like this, and we'll call it recursively. And what will be the base condition over here on this, in this recursion, is if we try, if this is the root, suppose if 2 is passed over here, so the 2.left won't exist, so that is the base condition. So that means it will, if any time our root becomes null or it is empty, so what we'll do is we'll try to just, it is a base condition, we'll try to just return. Okay, so if root is equal to null, or in JavaScript we can write it as not of root, not root. If we don't have root, then just return. Okay, if not root, then just return. So that is our base condition. So this will kind of traverse the tree. So this recursive function to traverse our tree is kind of will be called with the root here. Okay, so we call this function with the root. So this is like normal traversal of a tree. So what we will do with these roots now? So let us try to understand. So what will happen if we just call this function? So this LOT will be called with root1, and then it kind of calls this function again with root.left, which is 2, and then similarly it will just go on each and every node, right? Makes sense? But what we have to do is, remember the problem what we were trying to solve. We will kind of make these buckets, and in each bucket we will just push in that each and every element into its respective bucket. Okay, so for that we should know something. Okay, we should know at what level we are at. So how will, if we are traversing the tree, how will we know that at what level we are at? So if we add 2, so how will we know that the level is 1? So for that what we'll do is we'll keep a track of the level also. So initially let's keep our level as 0 over here. So we'll keep our level as 0 over here, and then as in when we are moving towards left or we are moving towards right, what we'll do is we'll try to increase our level number. So now the level number when we move to 2 becomes 1, that's a 0 plus 1, and over here for 3 also it becomes 1. If we are moving, anytime we are moving towards left or towards right, if we are going down the tree, we will try to just increase the number of level. Okay, so over here the level becomes 2. So how will we do that in the code? So for that, let us try to start with 0 first. So okay, so this function will also contain one more input along with root, that at what level this root is. Okay, so initially this root, what we passed over here, this root which goes 1 over here. Okay, so this root will be 1, okay, 1, and the level will be 0. So let us introduce one more parameter into this function, which is known as level. Okay, so this level initially will be 0. Okay, will be called with 0 because first time the level will be 0. And over here, let us introduce one more parameter, which is known as Okay, so every time we call this function again, we will try to increase the level. So first time it came with 0. Now when we are going to left or we are going to right, we will try to increase this level. Okay, so this will be level plus 1, and similarly when we are going to root.right, that should also be level plus 1. So now comes the main part. What we have to do is, now we have to put this individual root inside this results of array. Okay, so we have to pick these roots and we have to put it into their respective buckets. And how will we get that? Okay, which bucket to put in, we'll get with this level. So let me tell you how. So first of all, suppose when the initially our zigzag method will be called with this root 1. Okay, and we will call our recursive function with root 1 and the level 0. So over here the root will be 1 and the level will be 0. So what does that mean now? So when we have 1 and level 0, so what we'll do is we will put in this root 1 into bucket 0. Make sense? Into results of 0. We'll have to push in into results of 0. And then what will happen? This function will be called again with root.left. This time the root.left will be 2 and the level will be 1. And what will happen is we will again put the 2 when this function will be called again for 2. So that 2 will be pushed into bucket of level plus 1. So how will we do that? So we will kind of put in results of level dot push, and what we will push? We will push the root dot val. Makes sense? So root dot val is the value 1, okay, and it will be pushed into results of 0. So it's like results of 0, we will push 1 inside this. And what will happen in the recursive call? It will call this function again for root.left. Root.left will be 2. Okay. And level plus 1 will be 1, and it will call again. So this time 2, 1. Okay. So this time it is 2 and 1. And results of level, results of 1, that means results of 1, we will push in root.val. Root.val is 2 this time, something like this. And similarly, these recursive calls will call it for each and every time. Okay, so root.right will be 3, and this time also again we will push level plus 1. So level plus 1 is 1, right? So 3 and 1, so 3 and 1, and now results of level, results of 1 will get 3 also. We will push into 3 also. Okay, so makes sense. And then again we will do the same thing for each and every row. So this kind of maintains our levels and kind of traverse the whole tree. But can you notice one problem here? There is a one problem over here. So the problem over here is that initially when we call this root with 0, 1 and 0, so what happens is it goes over here and the results of level, that is results of 0. So our results at that point of time is an empty array, right? And if we try to do results, so what goes first time? 1 and 0, right? 1 and 0. So if we try to push in 1 inside results of 0, so results of 0 right now is what? If you know JavaScript, the results of 0 will be undefined. So what happens is this line will fail. So initially what happens is, see, our array results is empty, right? So we have to kind of create these buckets also. So do a push only if you find that bucket exists, otherwise you have to create a bucket. That is whole the gist over here. So how we'll do that is, so we will only push if results of level exists. Okay, so let's try to check if our results, so before doing this, let's try to check if our results of level exists or not. Okay, if results of level exist, then only push this results. Okay, so that means initially if it goes 1, 0, so 1, 0, the results of level does not exist at this point of time. So don't push it, but instead create this bucket. Okay, so create this bucket and push it. So something like else results of level, if it is not there, then do a results.level equals to root.val, and else will be closed over here. So it kind of looks messy, right? Let me explain it to you once again. Okay, let me explain it to you once again. Let me just remove these also. So just check this piece of code. Okay, so just check this piece of code. Okay, so what this piece of code will do is, so initially our results will be empty. So initially our results will be an empty array. Okay, empty array. So what we have to do is we have to kind of put in these elements into respective buckets, but buckets are not created. Okay, initially our array is empty, so buckets are not there. So what we will do is, if we call this root with 1 and 0, okay, 1 and 0, so at this point of time results of 0 isn't there. Okay, so we will check if results of level is present or not. So we don't have it right now. So what we will do, we will go to else condition and we will create a results.0 equal to root of val. So what does this line mean specifically? This statement, else statement, it will create a results of level and put in root.val inside an array. So what I am writing over here is, we'll do results of 0 will be array with root.val. So something like this. Make sense? So now when we will go to if case, we'll come over there. Okay, so then it goes to root.left level plus 1. So now the root.left is 2. Okay, this is 2 and this is level plus 1 is 1. Okay, so this will go to 2 and this will go to 1. So now again it goes to this condition, not of root return. Okay, so the root exists. So now we go to if condition. So we'll see results of level, results of 1 exist. No, it does not exist, right? So it is undefined. So this condition will fail. It will go to else condition. It will be like results of 1 equal to root.val. Again, the root.val over here is 2 and results of level we will create because it was not there, and we will put 2 over here. Now with the recursion, it also goes to root.right and level plus 1. Okay, level plus 1. So now the root.right, when it goes to root.right, so this time it will be 3 and the level will be 1. So this root will be 3 and the level will be 1. So what does that mean? Now it checks if results of level exist. So yes, this time the results of level is there. Okay, so there is results of level. So this condition will pass. Now it will do results of level dot push. So that means it will push the results dot value, root dot value 3 into this bucket itself. Okay, bucket number 1, level 1. Okay, it will push it into like this. And similarly, once we are doing this for 3, it goes again and checks, it executes this LOT of root.left. So this time root is 3, so it goes to 3.left 4 and it will pass level plus 1. So level plus 1 will be passed 4 comma, this will be called for 4 comma 2, and for again the next call will be 5 comma 2. Okay, so this will be 5 comma 2. So when it executes this statement, it goes to here, and if it checks yes, root exists, so this it will go to next if condition. If results of level, so results of a level does not exist for now, so root dot level, results of level dot push won't execute, but it will go to else case mein results of level equal to root dot val. So that means results of level, this time the level is 2. Okay, level is 2 and the root of left is 4. So what will happen is 4 will be pushed into results of 2. This is results. Okay, 4 will be pushed into results of 2. And what will happen next time? It will be called with 5 and 2. So 5 will be pushed over here. So something similar. So this code will kind of run again and again and will create our this set. And this is the normal level order traversal. Do you see? 1, 2, 3, 4, 5. This is normal level order traversal where each and every bucket represent each and every level of this binary tree. So now after execution of all this results array will be created. Now at this point of time, after all this is done, so we got this. Now what we need to do is just the last step where we need to reverse our these buckets which are present at the odd index. Okay, odd index. So 1, and if there exists 3, so we had to reverse this also. We have to reverse this. So how will we do that? That is also simple. Instead of returning the results here, so what we'll do is we will try to reverse the odd indices. That is very simple. Okay, so we have this array. We'll just do a map. So what we'll do, results is equals to results dot map, and this map function takes 2 input. Okay, takes 2 input. First is the bucket. Okay, this bucket B, and the index. Okay, and the index. So now this map function, let me write it over here instead. Okay, results dot map takes bucket and I, and what it will do is if our I mod by 2, okay, if it is 1, so if I mod by 2, this will go inside. If I mod by 2 is 1, I mod by 2 1 means odd. If it is 1, so what it will do is it will try to reverse it. So it will return, if I mod by 2, so it will do b dot reverse and return. Okay, otherwise else just return b. Okay, so for each it will kind of map it, and in each map, if our I mod by 2 is equal to 1, so it will just reverse, else it will just return it normally. So for each and every even case, it will just return the b as it is, and for the case of odd, it will just reverse and return. So instead of this if else, we can just write a ternary operator over here. So something like this. Maybe let me write it once again. So it will look something like dot map b comma I. B represents each and every bucket and I represents the index. And if I mod by 2, okay, so if it is odd, so what happens is it returns, let's put the ternary operator b dot reverse, else just return b. So that is it. So now the results is results dot map bi. If I mod by 2, if it is odd, then it just returns b dot reverse, else it just returns b. So it kind of returns odd for the odd ones, and even for even ones, it just returns b. So now the results will look something like this 1, and then these will be reversed. Okay, and this will be same 4, 5. So now we can just return our result. This was the code, and what we'll try to do is now we'll go to the Leetcode platform and we'll try to put in this code as it is, and we'll check if it works or not. Okay, so this is a Leetcode medium problem, and most of the times I have seen these companies like Amazon, Microsoft, Google, they ask a lot of Leetcode medium problems in their interviews. Okay, because see, Leetcode hard problems are a little harder to solve in that interview time span. So, and easy problems are way too easy. So most of the times these big companies ask Leetcode medium problems. So that is why it makes this problem a very good problem to ask in interviews. So that kind of checks your recursion thing and how do you manage things, and it's a good problem to solve. So let's see on the Leetcode now. So this is the binary zigzag level order traversal on leetcode.com, and this is a Leetcode medium problem. And see, this is the description, and it's the same example which we took it while solving it on whiteboard. And let's move on to the companies section. So if you see in the companies section, it has been asked a lot of times in Amazon, Microsoft, Apple, LinkedIn, Facebook, and even in Samsung interviews, and even in Google interviews, Walmart lab interviews. It has been asked a lot of times. Okay, so this is a very hot trending question which is being asked a lot of times in interviews. So let's try to write the code for it. So in this Zigzag level order traversal, so if you remember, what we did was we create a results array. Okay, and we'll keep our buckets into it, and then we'll just return this results. Okay, makes sense. Now what we did, the next step was to create a recursive function, level order traversal, which takes two inputs, root and a level, remember? And what it will do is it will just traverse the traverse the tree. So how will we traverse the trees? We'll make a recursive call with root.left and level +1, remember this? And we'll do the same thing for root.right and level +1. So that's it. And then never forget in recursion the base case. So the base case was if root does not exist, then we just return simply. Now this call will be made first time with the root, remember, and the level, yes, you're right, hit 0. So with 0 we'll make the call again, and now we'll write the main logic here. So main logic. So main logic to form buckets, what we'll do is, so what we did was in the results, if, okay, yeah, so if results exist, results of level exists, okay, results.level exists, so just push our value into results.level, okay, root.val. This is how we do, right? And else we just create it. If it does not exist, we just create it within root.value. So this is for the first time, this else case is for the first time, and this is for the rest of the times. You just need to push it. Let's put a semicolon. Okay, so this is the main logic over here, and then this is just traversal of the tree with level +1. Okay, so now, so main, and the another part is like what we have to do is now results, we have to map it and like reverse the odd indices, isn't it? Odd indices with odd indices buckets, right? So let's do a map on it, and then it takes bucket comma index, and then what we'll do is we'll just, if the bucket is odd, how we'll find it's odd, we'll just mod by 2. If it is odd, then we'll do a b.traverse, or else we will just do a b. So this looks good. Did I miss anything? Let me check it once again. So I'll did a results, and then yep. So main logic, rows or level.push. Yep, this looks good to me. So let me just try to run this code for the test case. Yep, so it's accepted. Okay, so it's accepted, looks good to me. So let me just submit it once. So if I submit it, yep, so it is accepted. Yeah, but it's kind of faster than only 11.62% JavaScript. Let me try it once again. So Leetcode is kind of fun. So it increased, I don't know, it just like randomly might give you something else. I have seen a lot of times happening with this. Okay, no issues anyways. So this is what the problem was. So if you want this code, you can find it on, I'll put it onto GitHub, and we'll put the link in the description also, so you can go ahead and check out this code. But I would definitely like you to try it yourself, coding this, and then solve it on your own. You anyways have got the idea behind how you want to solve it. Now I need your help. So this was just an experiment video where I showed you that, okay, this is the DS problem and we solved it using JavaScript like this. So I want to know that whether you want to watch these kind of videos more or not. And if you want to watch these kind of videos, then should I solve more harder problems or similar type of problems or easier problems? What kind of problem can I solve? Or I just don't solve DS problems altogether in my channel. So I want to know this from you. Do give me a feedback definitely, and thanks for watching.